Hi, I'm Melanie Waters, and I kind of went from the point of view if a middle schooler came up and asked me kind of like a sciencey question, because I teach eighth grade science. So when we get into space, they always have tons and tons of questions because they always want to know what if and what that would happen. So for my reference question, I decided to do what happens to a person when they go into a black hole. And middle schoolers love to ask what happens because they're curious. They want to know, do you go into another dimension? Do you die? They don't know. So it's would be a really good thing to kind of collect sources and show them what it is. So I went into analyzing and thinking, what do I know about the topic before I went in to do searches for any of the resources that I might need. Okay. And again, we don't know librarians' backgrounds. They could have a background in anything. They could have been teaching like I used to before. So they could go off their prior knowledge. And I think a person would have to have a spacesuit on to survive the initial aspect of space and then go past a certain point in a black hole. But what happens after that? Well, I decided to go to Google first and type in what happens to a person when they go into a black hole. Usually, Google is one of those places just to get started, just to get an initial kind of definition or whereabout on what really we're talking about. So, on that Google search, it says if you leapt heroically into a stellar mass black hole, your body would be subjected to a process called spaghettification. No, really, it is. Again, the black hole's gravity force would compress you from top to toe while stretching you at the same time. Thus, spaghetti. So there's a good little start. And again, one of the little subtopics, they're going to be like, well, what's spaghettification? So I decided to go to the Thomas Cooper Library and I searched up spaghettification and looked at the first article. On that first article from, again, the Physics Education Journal, it started with a little article that said the little robot black holes and spaghettification. And I was looking to see if it would explain it even more. And we kind of got kind of another vague definition, which it says the tidal forces generated by a black hole can be so powerful that they cause unlimited stretching, known as spaghettification. So again, it's still just telling us a very vague definition. And when I went in to search for some of these things, a really good key fact is if you have the PDF of it or you're on a website, if you hit Control F, you can type in a word you're mainly looking for. So, again, that's a really good, helpful thing for when you're researching. So that way you can get down to the most specific thing you're looking for. So, again, I went back and looked to see what else I could find for spaghettification. And within that article, I went down again a little bit farther and still found the same thing where it says the tidal forces generated by a black hole can be so powerful that they cause unlimited stretching. Still very vague. So I went back to the Thomas Cooper Library database and I went in and found another article on there. And within that, it said by studying the event horizon through both theory and observation, scientists could soon figure out how the universe began and how it evolved and even predict its ultimate fate. They also be able to answer a crucial question. Would a person falling to a black hole be stretched and flattened like a noodle, dying by spaghettification, or be incinerated? So there's another little definition getting even more into it. They said you'd be stretched and flattened like a spaghetti noodle, but it also in there says you kind of have to go again uh past the event horizon. And that kind of took me back to my question where I said it has to go past a certain point in a black hole. So I'm thinking maybe that's what it's called, the event horizon. So I went in and I searched for the event horizon. I went through Discus through my public school account to just kind of see if they had it in a little bit more simpler terms for my middle schoolers to look up. And within that, I found that it says that two freaky effects would color your final approach. A looming darkness would wash over your eyes as the black hole seems to grow in size much more quickly than you would expect, and the surrounding stars would start to distort and bend. This is your last opportunity to escape. Any further, and you would cross the event horizon, the line where the black hole's gravity is too large to resist. And I'm like, all right, that answered my question. There's the certain point it has to go past. Again, it's called the event horizon. And then I continued down through the article and it told me more about spaghettification. And it said, and then your body would undergo spectacular tortures. The gravity inside a black hole increases so quickly that it wouldn't just crush you, but pull apart every part of your body at different speeds, resulting in spaghettification. If you fell in feet first, your ankles would stretch away from your knees before your neck elongated into a strand of linguine, and the difference in time would be small enough that you probably wouldn't notice. It would happen in the blink of an eye, which may not be the best expression since your eyes are going to pop out. And again, that would get my middle schools riled up because it'd be like, okay, this is what this says, this is what's going to happen. But I always want them to look at from a professional's point of view. So I went through and I looked at and thought of the question, but what do astronomers and astrophysicists think about spaghettification? What are they going to think about? So I went and looked through some other information systems and I found the Center for Astrophysics. And according to astrophysicists from Harvard and the Smithsonian, they give us a little bit more of a good, concise definition of what a black hole is. And it says a black hole are some of the most fascinating and mind bending objects in the cosmos. The very thing that characterizes a black hole also makes it hard to study. Its intense gravity. All the mass in a black hole is concentrated in a tiny region surrounded by a boundary called the event horizon. Nothing that crosses that boundary can return to the outside universe, not even light. A black hole itself is invisible. So, again, this is kind of tying in our event horizon. What's that point? What's it like? What's in there? Like, it's so much gravity that is pulling down on you. But they still didn't talk about our other subtopic, spaghettification. So, I kind of wanted to see if other scientists talked about black holes and spaghettification. So I went and looked at the Spartanburg Public Library e-reference. It's named Credo Reference. And again, you'll need a library card to get into this. But again, library cards are free and you just have to put in your number. And you can go in and you can look for pretty much anything that they have as an e-reference. And when I looked through it from a curriculum editor within a textbook, Andrew Solway states that it defies the region known as the event horizon, the edge of the black hole where the escape velocity equals the speed of light. And we talk about velocity and we talk about speed in eighth grade, so my kiddos would know what that means. And it says no one can ever know what takes place inside the boundaries of the event horizon. It is thought that the collapse in mass continues to shrink until it becomes a minuscule point of infinite density known as a singularity. And we talk about singularity and how that's a very, very, very tiny thing with a lot of mass. And objects crossing the event horizon are believed to disappear into the singularity. So, looking at it from the point of view from a curriculum editor and other astronomers and astrophysicists, they still don't talk about spaghettification. They just kind of tell us what the event horizon and what a black hole is. So, I decided to go for a visual point of view. And I found that NASA has a perfect infographic that gives you the basics on black holes. It even has a description of spaghettification from astrophysicists. And it's not just 1 through 5. I think it went through 1 through 15. But for that infographic, it's really great that they can show their peers, be like, hey, this is what this is NASA talks about. And for spaghettification, they say it's a real term that describes what happens when matter gets too close to a black hole. It's squeezed horizontally and stretched vertically, resembling a noodle. So there we go. We still got astronomers and astrophysicists telling us what it is. And sometimes kids like to see kind of like a display of it. And another resource I went through was YouTube. There's a channel called Crash Course, and it has different people that come in and talk about this. This specific one on black holes was by Phil Plait. He's an American astronomer, and he goes throughout this video, tells you what it's like in a black hole, and it gives you a little, as you can see, a little cartoon display of what spaghettification might look like and what it's like inside of a black hole, and all these other basic things. And also, I was like, all right, there's one video. Let's see if there is something else. And I found the What If channel, and it's a Webby Award winning science web series. Again, each scenario examines a scientific theory, research, or fact through a hypothetical question. And this one is, what if you fell into a black hole? And they always try and go through and make sure they're getting the scientific evidence behind it. And in this video, they also talk about spaghettification and what it's like in a black hole, for again bringing more and more information into them so that way they can answer their question. And the last one I kind of found, NASA has a podcast, and this one is called Inside a Black Hole. And Capito and Shipman, they talk about, again, what it's like inside of a black hole. And the host is Capito, and one of the astronomers is Shipman, and they go in and talk about what it's like. And again, talk about the event horizon, talk about the point to where nobody can return, and spaghettification, and everything else that they could be curious about. And they also have other things that they talk about throughout this. So this has been going on for a while through NASA's website. Okay. And once I compile all this and then I can give it to them so they can look at it even more, it's going to help them once again. Once given all of these resources, they can answer the question, what happens to a person when they go into a black hole? And ultimately, for that answer, it would be kind of like what my answer said. They would need a spacesuit, ultimately, to, again, survive initial space. But again, they have to go past a certain point in the black hole. So the black hole's not going to suck you in. You have to go past the event horizon, and then it'll slowly start stretching you head to toe or toe to head out so far and stretch so wide that you become a noodle, but you don't know what's happening to you. Everything seems to kind of stop. And again, you undergo spaghettification. So with that, that's how I kind of wanted to look at a reference question, because there's so many good resources out there to answer this question. And these are my references. Again, I am going to attach my references sheet to the document on Blackboard.